Okay, and welcome back. Good morning to all. Next, today I'm going to discuss about the cipher feedback mode or CFB mode. In this mode, the cipher is given as feedback to the next block of encryption with some new specification, and fast and initial vector is used for fast encryption, and output bits are divided as set of SAND BS bits in the left hand side, and S bits are selected or applied on XOR operation with plain text bits. The result given as input to a shift register and the process is continuous. So in the CFB mode is useful in such cases. In this mode, data is encrypted in units that are smaller, and like CPC, a 64-bit initialization vector IV is used in case of CFB mode, and the IV or the initial vector is kept in a shift register. It is encrypted in the first step to produce a corresponding 64-bit ciphertext. Next is in the second step 2, the leftmost J bits of the encrypted initial vector IV and XOR with the first J bits of the plain text. This produces the first portion of the ciphertext SC. Step 3 is now the bits of initialization vector IV are shifted left by the position, and thus the rightmost J position of the shift register now contain unpredictable data, and their rightmost J position are now filled with C. Now the last step is your IV now is encrypted, or the initial vector is encrypted. The leftmost J bits resulting from this encryption process are XORed with the next J bits of the plaintext. The resulting ciphertext portion is sent to the receiver. The shift register containing the 4 is left shifted by J bits. The J bits of the ciphertext are inserted from right into the shift register containing the initialization vector. So this is your CFB method. Next is your output feedback mode or OFM method. In the output feedback method mode, or you can say output feedback mode, is extremely similar to the CFB. The only difference is that in the case of CFB, the ciphertext is fed into the next stage of encryption process. But in the case of OFB, the output of the initialization vector encryption process is fed into the next stage of encryption process. Therefore, we shall not describe the details of OFB, and instead I'll simply draw the block diagram of the OFB process. Now let us summarize the key advantages of OFB mode. In simple terms, we can state that in this mode, if there are errors in individual bits, they remain errors in individual bits and do not corrupt the whole message. And that is, bit errors do not get propagated. And if a ciphertext bit CI is in error, only the decrypted value corresponding to this bit, so PI is wrong. Next is your PI means is your plain text P1, P2 to PA. Other bits are not affected, and remember that in comparison with the CFB mode, the ciphertext bit CI is fed back as input to the shift register and would corrupt the other bits in the message. So this is about the output feedback mode. Next come to the counter mode. Counter mode or CTR mode is quite similar to the WebP mode, and it is a simple counter based block cipher implementation. Every time a counter initiated value is encrypted and given as input to XOR with plain text, which results in ciphertext block. The CTR mode is independent of feedback use and thus can be implemented in parallel. So it uses a sequence numbers called counters as the inputs to the algorithms. After each block is encrypted, to fill the register, the next counter value is used. Usually a constant is used as the initial counter value and is incremented usually by 1 for every iteration. The size of the counter block is the same as that of the plain text block. So this is the encryption counter value is there, and every time the counter initiated value is encrypted, and k value is the key value is given, and this is the P1 plain text, and this is C1 is the ciphertext. So this is the about the counter mode. Next is your overview of symmetric key cryptography. Here in the symmetric key cryptography, everybody knows that as the previous discussion that in symmetric key cryptography, this is the plain text, this is the secret key, and this is the encryption process, and this is the decryption process, and this is the secret key. In the first thing in symmetric key cryptography, there are only single key is there. That means there only the one key is given. That means it is the public key is given, and the same key is used for both the encryption and the decryption process. This symmetric key cryptography is also known as private key cryptography. In this scheme, only one key is used and the same key is used for both encryption and decryption of messages. Obviously, both the parties must agree upon the key before any transmission begins, and nobody else should know about it. Let's discuss about an example. Suppose this is the sender, and this sender now to the key transform the plain text message into a ciphertext form, and the receiver's end, suppose this is the receiver end, the same key is used to decrypt an encrypted message, thus deriving the original message out. Next is your in practical situation, symmetric key cryptography has a few problems also. The first problem here is that key agreement or key distribution. The problem is, in the first place, how do two parties agree on a key? One solution is that somebody from the sender's end physically visits the receiver and hands over the key. Another way is to courier a paper on which the key is written. Both are not exactly very convenient. A third way is to send the key over the network to the receiver and ask for confirmation. But then if an interviewer gets the message, then he or she can interpret all the subsequent ones. The second problem is very more serious because the same key is used for encryption decryption. One key per communicating parties is required. Suppose the sender wants to securely communicate with the senders equally communicate with the receiver and also with another party. So clearly there must be one key for all communication between the sender and the receiver. So there must be another distinct key for all communication between the sender and other party. The same key is as used between sender and the receiver cannot be used for communication between the sender and the other party. So otherwise there is a chance that the other party can interpret message going between sender and receiver can do the same message going between sender and other party. Since the internet has thousands of merchants selling products to hundreds of thousands of buyers. So this is the problem structure about this symmetric key cryptography. So thank you to all for today's class. This much. For next we will discuss another topic. Okay, thank you to all.